This is Mr. Anderson for Keller Community College. We're going to be doing Section 8, the complex numbers, in Chapter 7 of our Math 121 book, Intermediate Algebra. Now, the first thing I want to do is kind of give you a quick review of some of the vocabulary we may have picked up in Math 101. The natural numbers start with 1, 2, 3, 4, and go all the way to positive infinity. These are real numbers, so we're going to imagine these natural numbers in the center of our number universe, starting with 1 and going by whole numbers all the way to positive infinity. Now, whole numbers are almost the same size as the natural number set, except that whole numbers start with 0 and then go to positive infinity as well. So the difference between the whole numbers and natural numbers is we're going to be adding 0. So in terms of size, the natural number isn't that much smaller than the whole number universe. The whole number universe just has that 0 in it. So yes, these are all real numbers. The integers are what we're most commonly dealing with, from negative infinity to the negative numbers like -3, -2, -1, including 0, and all the positive numbers going to positive infinity. The real numbers are real, and they also are much bigger, because it would be all of the whole numbers plus all the negative natural numbers. So this is the integer number universe, denoted by the capital letter I. The rational number universe are a series of fractions, all the fractions that we can create that can be used, including ones with repeating decimals, like 7/9 or 3/7. Improper fractions are also included in this list. You can have anything over something else that can be reduced or can't be reduced. These are all real, and if you can imagine, the rational number universe is a lot bigger, because between every two integers is an infinite number of fractions. So the rational number universe by the capital letter R is quite bigger. Now, the irrational number universe is even bigger than that, because attached to every single rational we can attach an irrational number. Now, irrational numbers are square roots that cannot be simplified any further. So for example, the square root of 3 cannot be simplified any further, or the cubic root of 5 cannot be simplified any further. We can also make up decimals that can never ever be represented by the whole numbers there. So for example, if we put 0.12111211112, if we come up with a pattern here, this would be an irrational number that never could be repeated. Pi is another example of the rational number, or square root of 2. And they are real numbers, but their universe is bigger because we can attach one of them to every single fraction that we can make. So the irrational by IR is the example of how much bigger they are. Now, attached to every single irrational number or anything like that, we have imaginary numbers. And the one that we're going to be talking about today is going to be the square root of -1, which is I. The square root of -1, as we've seen before, is an imaginary number. It is not real. It is not a real number, and therefore we have to consider it as such. But it would be a bigger universe, because we can attach an imaginary number to any of these previous, and that's what we're going to be working on today. So the lowercase I for imaginary numbers is the square root of any negative. All right, moving on to some examples here on the first page, which will finish our first part of the video here. Okay. Now we have to simplify and write all our answers in a+bi form. The form a+bi, which is a little bit off the screen here, but let me rewrite it here. a+bi, this is the number in front of the imaginary number, and this would be any whole numbers or any integers that would be removed from the front. They also could be irrational too. But you'll kind of see this pattern pop up the more we go about this, and this gets us also prepared for working with any answer with the quadratic formula in the next chapter. So we're looking at the square root of -9, which is the same thing as the square root of -1 times the square root of 9, using my product rule from an earlier section of the book. So the square root of 9 is 3, and the square root of -1 is I. And that right there is my answer. Now what we're going to do is we're also going to assume that none of these variables and numbers here were taken from negative numbers, so that way we won't have to work around the plus or minus clause here. So this is going to be the square root of -1, which is I, and the square root of 9, which is 3. Notice that the whole number goes in front of the letter. Here we have the square root of -12, so we're going to take the couple things here. We're going to take the square root of 4, the square root of 3, and the square root of -1. The square root of 4 is 2, the square root of 3 is just 3, and the square root of -1 is I. So if we ever see a negative inside of any even power, we're going to take it out as I. Now right here, you'll notice that this is, I can rewrite this as negative times the square root of 81 times the square root of -1, which means I got -9 times I. The 9 right there is from the 81. The -1 makes the I, and the negative does not change the letter I. So multiplying I by -1 is just -I. Looking at number 4, we've got 4 minus the square root, and this is going to be broken up into 16 and 5 and -1. Because 60 can be divided by 16, that's the biggest factor it can get simplified by. And that leaves 16 times 5, which is 60. Factor out the -1 to get my letter I. So 4 minus 4 square roots of 5 times I. And the book might factor out a 4 here, but it's not really necessary since the form is a plus bi. So there's my a plus, which in this case it's a -4 square roots of 5. That's my b, and then my letter I. All right, let's see what this breaks up to. 72 can be divided by 36, which can be then divided by 2. 36 times 2 is 72, and there's my -1 right there, minus square root of 25 times square root of 1. So this is going to be 6 square roots of 2i minus 5i. Now you'll notice that we want our problem in a plus bi form, but we have 2 i's in this case. So let's factor the I out and have my 6 square roots of 2 minus 5 inside of a parenthesis. So this is my a is 0, my b is a binomial, 6 square roots of 2 minus 5, and my I is just I. Now here, this is just a distribution problem where I'm going to distribute my negative. So 8 plus 7i minus 2 minus 4i. Now 8 minus 2 is going to be 6. 7i minus 4i is just positive 3i. Problem number 7, this is another distribution problem of the negative. Negative 2 plus 6i plus 7 minus i. Negative 2 plus 7 is 5. 6 minus 1 is 5i. 7 times -8, this is going to be -56, and this brings up a pretty interesting point. I've got I times I, which is going to be I squared. Now, here's the funny thing. I squared has a property, and it's if you have I is equal to the square root of 1, just the square root of 1 there, I squared would be the square root, I'm sorry, that's a -1. That's where I made a mistake. Okay, hold on, let's start over. I is equal to the square root of -1. So I squared is equal to the square root of -1 squared. So that means I need 2 of these. So I squared is equal to the square root of -1 times the square root of -1. And that means I squared is going to be this right here, -1 times itself to the second power under the square root. -1 and -1 is 2 of these, which means we can take this, as you see I've broken this down up here and put it back together. The square root of any number squared is going to be itself. So if you have I squared, -56, times -1, I squared is -1. There you go. I squared is -1, so our answer here is 56. All right, keeping this on the same page, let's look at this. We got -6 and -7. Now wait, before you take your pull the i's out, Well, that sounds bad, doesn't it? Before you remove the negatives here, you can put this together using your multiplication laws, the product rule. The -6 and -7 makes positive 42. And 42 can't be broken down any further, so that's your answer. You'll notice you have no letter I because these two negatives made a positive. Now for problem 10, I will kind of move this down, which will erase my information here, just so we have a little more room to deal with problem 10. Alright, so let's go distribute. Whoops. There we go. Distribute that, distribute that. So this is going to be 14i plus 6i squared. Now the 14i stays exactly the same, but as we learned before, I squared is equal to -1. So this is going to be plus 6 times I squared. So that makes 14i minus 6. And because we need to write this in a plus bi form, we need to have the -6 in front plus 14i in back. My a is going to be -6 and my b is going to be the 14 and then my letter I. Alright, that's the first of 2 videos. Stay tuned for the next portion.